Hey everyone, so today we're going to talk about total area and distance traveled. Okay, so one of the biggest things we can take away from this is this idea, we've talked about this before, that when we're talking about a definite integral, it's the signed area under a curve, meaning above the x-axis is positive, below the x-axis is negative. And when we're talking about the area, we're talking about the total area, meaning everything's positive. So let's just take a look at this first example. It says region A is 14, area of region B is 16, and area of region C is 50. So if we were to evaluate this integral, we would have 14 plus below the x-axis, that area is negative 16 then, plus 50. Okay, so our definite integral from 0 to 8 would be 48. So taking that negative into account. All right, now, same exact graph here. Take a look at part B. It says find the area of the region bounded by f of x on the x-axis. So find the area of the region bounded. When it has this word here, we're talking about all positive area here. So talking about the total area, meaning we'd have 14 plus 16 plus 50. Or you can even think of it as the absolute value of negative 16 plus 50, and we would get 80 is our total area, versus our definite integral is 48 since we take away that negative area. Okay, so that would be the biggest thing to collect from there. Let's take a look at how to find it with a graph. So same kind of idea here. The area between f of x and the x-axis is this idea of the absolute value of the function. Notice it's inside. It's not the absolute value of the integral. Okay, that will give you a different answer. The absolute value is inside. Okay, absolute value inside the integral. And that's actually how we're going to do it on our calculators. In a general sense, here's what you would see, right? You have this curve. If you were to take the absolute value of f of x, anything that was below the x-axis is going to be now above. Okay, so those areas now would all be positive when we take the absolute value of the function. Okay, so these are the TI-89 instructions. So TI-84, I mean, yours is typed pretty nicely for you. You guys would go to math 9, get this little setup here, okay, and just make sure when you type in your function, looks something like that, that the absolute value is inside. Okay. If you're looking for that absolute value button, if you guys click math and then you scan over to number, I believe it's number 1 right there to click absolute value. But again, make sure you go to math 9, type the integral, then type the absolute value. Okay? So what if we don't have a calculator? What if this comes up on a non-calc part? We're going to have to talk about basically splitting up. So think of it this way. We're going to find this area. Then we're going to find this area, make it positive. Then we're going to find this area and add those 3 things together. So we're going to have to find the zeros. And then we're basically just going to split them up. So we'll go from A to this value minus this value to this. Again, we'll kind of think of it as a double negative. And then last but not least, this value to B would be positive. So again, I think it's kind of easier to look at an example. So take a look at number 1 with me here below. So number 1 is 9 minus x squared. I'm just going to draw this. You don't have to draw it if you don't want, and we're not going to normally draw. But let me just give you a visual of what's going on here. So we're going from 0 to 5. 9 minus x squared is 0, 9. It's this half of a quadratic here. It intersects at 3, 0. And if we're going to 5, if we went down here to 5, if you plug in 5 here, 9 minus 5 would be negative 16. So something like that. This is 0, 9. And if we're looking for the area between, I just wanted to show you kind of what that would look like. You'd have this area between the x-axis and the function. Then, so you start at 0. You go to 5. Remember, you're looking for between the function and the x-axis. So it's actually kind of this triangle piece right here. All right, so you have some positive area and some negative area. Now, when we're taking the definite integral, aka this, right here. We're not worried about really we can think about what the graph looks like, but we don't have to split anything up because we're taking into account positives and negatives. So you would just do this like you always did, which is we're doing 0 to 5 of 9 minus x squared dx, taking that integral there. So it would be 9x minus x to the third over 3 from 0 to 5. All right, you'd plug in 5. You end up with 45 minus 125 over 3. Plug in 0. Overall, you get 10/3. Okay, so what does that mean? Well, that means we get a lot of positive space. We took away some negative, so we ended up with, a little bit of positive, 10/3 specifically of positive area there. So if I ask you now, find the area of the region bounded by f of x in the x-axis, what we're going to have to find is this area plus this area. We're not going to consider it negative. We want to find that and add it. So there's a couple ways to do this. Again, the main idea here without a calculator is we want to find when is f of x equal to 0. I already kind of ruined this for you guys because I showed you the x-intercept, but it would be when x is equal to plus or minus 3. On 0 to 5, we really only care about x equals 3. Okay, so by the way, if you were in a calculator, what are you really doing? You would just go 0 to 5, absolute value of 9 minus x squared dx, and you would get your answer. That would be the end of the problem. So this is for no calc, okay? Because we can't really do this by hand. We don't have the tools in calculus right now to do the integral of an absolute value, right? So we're not going to be doing this by hand. We're going to be splitting it up. How do we do that? Well, we figure out again where it's equal to 0, okay? Then, we can see it in our graph. It's positive before 3, and then after 3, it's negative. So we'd split this up from 0 to 3, 9 minus x squared dx, plus we've got from 3 to 5, same function. Okay, the biggest difference here, though, is because this is negative, we're going to throw a negative in front. Or basically, you can think we are going to subtract negative area. What happens when we subtract a negative? It's just going to turn into a positive. Okay, so that being said, we'll just calculate both of those pieces. Let's say we didn't have a picture. Okay, so if we didn't have this graph where we knew this is the negative part, okay, what you would do is you would make a little sign chart for yourself from 0 to 5. You would fill in any x-intercepts, aka 3, and then just plug in something. So 9 minus x squared. 9 minus 1 squared would be positive. 9 minus 4 squared would be negative. Okay, so I know I'm going to be adding this integral and subtracting this integral so that we get that positive area. All right. Another way to think of it is you could technically just find this integral by itself, make it positive, this integral by itself, make it positive. So let's try this method really quick. Again, we're just going to be calculating both of these. Oops, sorry. So I'm not going to show all my calculations. We already know that this is 9x minus x cubed over 3 from 0 to 3. And then now, if you want to write plus negative, we could just say minus 9x minus x cubed over 3 from 3 to 5. Okay, if you don't mind, I'll just do this for you here. So if you plug in 3, you get 27 minus 9, which is 18, minus if you plug in 0, you get 0. And then this guy, so these are the two things we're doing, minus, if you plug in 5, you get 45 minus 125 thirds. Plug in 3, you get 18. So this would give you negative 44 thirds. So for the sake of the video, I'll just do that calculation for you. You guys should feel comfortable doing f of 5 minus f of 3. And what happens? Well, we end up adding 18 plus 44 thirds, which gets me 98 thirds. So a lot more positive space, right? We only had 10 thirds because we took away the negative. Now when we take the positive and add that negative, we end up with 98 thirds. So again, one way you also could do it, you have to split up the integral. So you can write yourself a note. You have to split integrals at the x-intercepts, okay? And then you either can do a sign chart if you want. That was pretty quick. If you don't feel like doing a sign chart, you also could just do one at a time. So I would do, this integral, if it's a positive number, I keep it positive. If it's negative, I make it positive. Then you would do this answer. I got negative 44 thirds. Well, I'm just going to add 44 thirds. So if you make every individual integral positive, that's another way of thinking about it as well. Either way, 98 thirds, final answer. You definitely have to do this step. Just kind of depends on how you want to split it up at the end. Typical recommendation, subtract any negative area to get that positive. Okay, so let's move on. Last thing we're going to do here is linear motion, which is talking about position, velocity, acceleration. So just to remind you here of some letters I'm going to use. S of t represents position. You've got V of t represents velocity. And A of t is acceleration. So in case you're wondering, when I mention those, that's what I'm going to be referring to. Okay? So we kind of have this little stack here, right? We've got S of t, V of t, A of t. If we are going to, we have position, we want to go to velocity, or we have velocity and we want to go to acceleration. This is where we're differentiating. E8. AKA take the derivative, right? So if we take the derivative of position, we get velocity. Take the derivative of velocity, we get acceleration. And then going the other way, guys, if I have acceleration, I want to go to velocity. If I have velocity and I want to go to position, we're going to be integrating. Okay, so, and we've done this before, but this is just review. Okay, the other biggest things that are going to come up that we want to write down is talking about finding the average velocity, average acceleration, etc. So let's write these down. We talked about average value recently, and we'll actually bring that in here as well. I'm going to use this tool, so my handwriting's a little neater here. Okay, so if I ask you for average velocity, okay, and you're given the position function, and you want to go from A to B. Okay, we've done this one before. This is basically a rock, and you use position, S of B, position at B minus position at A over B minus A. All right, what about this situation? If I ask you for the average velocity given velocity, this is new, okay? If you have velocity, the function, and I say, all right, give me the average velocity, from A to B, this is average value because you have velocity and you're looking for velocity. So this would be 1 over B minus A to B, V of t dt. Okay, so average velocity given a position function, you can use a rock with position. If you're given velocity and you're asked for the average velocity, then just use the average value function. This is what that is, average value of a function. Okay, really similar here, guys. If I ask you for average acceleration, hopefully you can kind of do some guesswork here, but I will write both of them down, of course. Okay, if I ask you for the average acceleration given velocity, so given kind of one function below on A to B, then we would do average rate of change of velocity over B minus A. If I ask you for average acceleration and you're given the acceleration function, that's all you have on A to B, then again, this is 1 over B minus A to B of A of t dt, aka finding the average value of acceleration. Okay, so make sure you got those down. Those will be helpful and definitely things you should feel comfortable with. They do come up in a lot of FRQs on AP. Okay, displacement, we've talked about this before. Net change in position, aka the integral of V of t. Okay, final position, you just take wherever you started plus your displacement, right? So if I started, 10 miles west and then I have my displacement, I find that. Final position. This is new, distance traveled. Hopefully you guys kind of recognize how this is going to fit in here. Distance traveled is a lot like area. So there's no direction. And what I mean by that, I'll give you an example. If I traveled 5 miles east and then I turned around and traveled 3 miles west, my displacement would be 2 miles. Okay, but if I traveled 5 miles west and then traveled 3 miles east, and I'm asking how far did I go? I went 8 miles, right? That's how far I walked. I'm not just going to say, oh, I only went 2 miles. So distance traveled is basically making everything positive. It's kind of like that area under the curve situation where we're going to break it up into different integrals and talk about, it doesn't matter if we went left or right, we're going to add all of those distances together. Okay, so displacement, you just take the integral. Distance traveled, we're going to be taking the integral of the absolute value. All right, so very similar to this right here. Okay, so let's try out, we're just going to try A through E here. I'm not going to actually calculate the first two, but let's just talk about what we have to finish up the video. So particle moves horizontally, velocity is this. Okay, so we only have the velocity function so far, and we're given this original position. Find the average velocity given velocity. Okay, well, scan up to your notes if you need to. We're going to be doing the average value of velocity. So you'd plug this in, take the antiderivative from 1 to 4, and then multiply by 1/3, and that would be your answer. Okay, versus find the average acceleration given velocity. That's going to be v of 4 minus v of 1 over 4 minus 1. Okay, and you would just plug in 4, subtract what you get when you plug in 1, and divide by 3. Okay, so I'm not going to calculate those right now. Hopefully you feel okay doing those pieces. It's just kind of picking what to do, I think, is the tough part. So take a look at C. It says find the times when the particle's acceleration is 5. So you want to know when is A of t 5. All right, well, you're given velocity. Okay, that's t squared minus t minus 6. Acceleration is the derivative, 2t minus 1. When is that equal to 5? Add over 1, and you get t is equal to, this is in seconds, so 3 seconds is when the acceleration would be equal to 5. Okay, so again, kind of just reviewing how does velocity relate to acceleration, how can I get from one to the other, etc. I know this was tough, that chapter, and again, we got to bring it up. It is a really big part of calculus, and you want to feel comfortable going between these pieces of linear motion. So last two things here. How about find the time when the particle changes direction? So whenever you're doing these, I almost think it's like annotating. You should know immediately particle changes direction. That's when v of t changes signs. So you should have kind of a little hint for yourself of what you're going to be calculating. Okay, so if we take v of t and we set it equal to 0, we get 3 and negative 2. Time can't be negative. You make a little sign chart for yourself. And we start at 0 for time. I think we're just going, it doesn't give us an ending, so we'll just say infinity. We've got velocity. And 3, we just want to make sure it's going to be a turning point here. So we've got v of t, you're plugging in to this is what I usually plug into. It's just kind of quick. So plug in 1, you would get a negative times a positive, which is a negative. Plug in 4, you get a positive times a positive, which is a positive. What does that mean about position? That means I'm moving left. This means I'm moving right, aka at 3, we do change positions here. Or excuse me, we do change direction. So you would answer this at t equals 3 because velocity changes signs. Or you could say it changes from negative to positive. Okay, and the last one, we already kind of answered it. Find the times when the particle's traveling left. Well, we have it right here, right? It's when from 0 to 3, okay, since velocity is negative. And that's it for your explanation. You don't have to be fancy there. You just want to say velocity is negative. All right. So that's about it. We'll continue. We've got a couple more pieces here, finding displacement, distance traveled, aka some of that new stuff. A little bit of review, a little bit of new. So let me know if you need anything. Please let me know if you have questions, and thank you for watching.